isn't 0, right? What happens if we have that shift up or down? What happens to our circle? Okay, so what happens, we're actually going to have modified circles, okay? And that's what we're going to try to explore now. So what's going on? Okay, so first thing we're going to do is we're going to graph this in the Cartesian plane, then we're going to throw it into the polar plane, okay? So let's go through the analysis. Okay, what's D here? 5. Okay, so the midline is y equals 5. I'm going to graph that. So I'm going to put in my dash line. Okay. What's the amplitude here?
3.
Good. So the amplitude is 3. So from my midline, I'm going to go up 3 units and down 3 units. So I'm going to put a line in at y equals 8. And a line in at y equals 2. Okay, and now for this graph, we want to, where does this start?
At 0, 8.
Good. Starts at a maximum, and in this case, 0, 8, because this is a positive cosine. Okay, so we're going to put in our points, 0, 8, and then our next point's going to be a quarter period away. Quarter period's going to be pi over 2, because we don't have any horizontal changes. So it's going to be pi over 2, 5. And then pi 2, and then 3 pi over 2, 5, and then 2 pi 8. Okay, and now I will try to sketch this. And make, yeah.
Why is 5 our midline?
Because this is plus 5. D is 5.
Oh, so it's saying, okay, so for cosine, you start, okay, so either way.
Cosine starts at a maximum, and in this case, the maximum is at 1, y is 8.
Gotcha. So if it were 0, then that means it'd be at,
If it were a sine, it would start at 0, 5.
Right. But if for cosine, either way, like, it would start.
Well, it could start at 0, 8 or 0, 2.
But like if it were plus 0, I'm saying.
Oh, plus 0, then the midline would be at 0.
Right.
Yeah, and then we'd be getting a circle.
Right.
Right? Okay, so now we want to take points from this graph, and we're going to graph it on this polar plane. Okay, I'm going to put in a few other points that I calculated previously, just so we can get a nicer graph. Actually, I'm going to put those down. I'm going to do them down here. Okay, so if you either read them from your graph nicely, or if you plug them in a calculator. And for this one, we're going to need to have some more points because it's a little bit more difficult. I'm going to tell you what these values are. So if theta is 0, this turns out to be 8. We know that. We found that point already. Okay. If theta is pi over 6, this is 3 cosine pi over 6 plus 5, which you could estimate from your graph. What does your graph look like when it's pi over 6? Look on your graph. What does it look like on the Cartesian one? See how well we drew it.
Oh.
Pi over 6.
It's about 7.
It's higher, right? Oh, I'm off. 7 point. Yeah, it's between 7 and 8, right?
Mm-hmm.
Somewhere around there. So the actual value is 7.6. Okay, 7.6. If we go to pi over 4, what's your graph look like?
Pi over 4.
5.5.
So pi over 4 is in between pi over 6 and pi over 3. What do you have on that line?
That's only like 6.5.
Or 6.5, sorry.
Yeah, so it's actually at 7.1.
Oh.
Okay? So this is going to be 7.1. Everyone understand what I'm doing, right?
Yes.
I would just be plugging these values into the calculator. I'm just telling you what they are in the interest of time. Okay, pi over 3, you could look at your graph. That should be 6.5. Okay, and then we're going to get pi over 2 is an exact value we plotted. That was one of the points we plotted, which should be 5. And then 2 pi over 3 is also a nice value because cosine of pi over 3 is a half. And 2 pi over 3 is negative a half, so this is 3.5. And then 3 pi over 4, if you were to plug this in,
On
yeah,
a quiz, we would have like a calculator.
you would have a calculator. But once we do one of these, you don't need to do this anymore. Okay, so we're doing this the first time to figure out what is this, what does it look like, and then once we know what it looks like, we're never going to do this again. Okay, so, but if you were facing a new type of equation, then you might have to plug all these in. Okay, 5 over 6 turns out to be 2.4, and pi was a nice value we already got. That was 2. The other ones we're going to get by symmetry, so I'm not going to do the rest of the table. Okay, so all I did was either from your graph or with a calculator, we got a bunch of points, so now we can plot this. Okay, so I'm going to put all the angles on this polar grid. You do the same. Okay, so I'm going to do 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6. Okay? And now we're going to just plot these points, right? Each circle is 1 unit, right? So I'm going to plot 0, 8, and then pi over 6, 7.6, so just come in a little bit, and then pi over 4, 7.1, oops, I don't want a line, 7.6, pi over 4, 7.1, pi over 3 was 6.5, pi over 2 is 5, 1, 2, 3, 4, 5, 2 pi over 3 is 3.5, so 1, 2, 3.5, 2, 3 pi over 4, I'll get it from here, 2.9, and then 5 pi over 6 is 2.4, and then pi was at 2, 1, 2. Okay, now the rest of the points are actually just symmetric over the line 0 equals pi. Okay, so if at 7 pi over 6, we're going to be at 2.4, the same as 5 pi over 6. Okay, so we're going to reflect all these points over the line 0 equals pi. So I'm going to plot those three, let's see, 5 pi over 4 is going to be 2.9. Stop me if you're not with me.
You said 5 pi over 4?
7 pi over 6, 5 pi over 4 is 2.9. 7 pi over 6 is 2.4. 4 pi over 3 is 3.5. Okay, then 3 pi over 2 is 5. And 5 pi over 3 is 6.5. And then 7 pi over 4 is 7.1. And 11 pi over 6 is 7.6, the same thing we started with. And now we're going to connect these, and we're going to get what's called a Limacon.
Where did that person get that name?
I think it's Brown, sounds French. Okay, so this is symmetric over the line 0 equals pi. That's why I didn't list out all these other points. You with me on that?
Yeah.
Okay, so this is actually called a dimpled Limacon because it's not a circle. It's like a little bit distorted of a circle because we had that shift.
Right.
Okay? All right, let's go on to the next one. All right, so we want to do this next one. So we're going to graph 4 cosine x plus 4. Okay? So, let's graph it in the Cartesian plane, then we'll shift it over to the polar plane. Same thing. Okay, so what's our midline?
4.
4. So y equals 4. So I'm going to put that on my graph. What's the amplitude?
4.
4. So I'm going to go up 4 and down 4. Okay, so amplitude is 4. Okay, and where does this start?
8, 0, 8.
0, 8, because this is cosine, so it starts at a max because it's a positive cosine. And then we're going to put a point at 0, 8, and then pi over 2, we're going to be at the midline. So pi over 2, 4, and then pi 0, 3 pi over 2, 4, 2 pi 8, and we're going to sketch this. Okay, and now we are going to transfer points from the Cartesian plane to the polar plane. So I'm actually going to write some of the points on here, okay? So for these, I put them in my calculator, okay? So we have 0, 8, that we know. Pi over 4 is 6.8. Pi over 3 is 6. Pi over 2, we actually knew that was one of our key points. Pi over 2, 4. And then 2 pi over 3 is 2. Oh, I actually drew this one pretty well. That's like a first. 5 pi over 6 is about a half. Okay, and then pi 0 we know.
5 pi over 6 is what?
Sorry, it's got messed up. It's 1/2.
5, cool.
About 1/2. These are, some of these are approximations, right? Okay, so I'm going to take these points, I'm going to put them on the polar graph now.
What was pi over 6?
Pi over 6 is, I skipped that. 6 point, oh, I didn't do that one. Pi over 6 is 7.5. So I'll write that here. Pi over 6 is 7.5. Okay, so I'm going to put the angles on. So 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3. You get better at it, you know, you do this a bunch of times. Pi over 6, pi. 7 pi over 6, 5 pi over 4, 4 pi over 3. I should fix that, it doesn't look so good.
Wait, what was the last one?
4 pi over 3?
Like, could you go up a little?
Yeah, sure. Is that better?
Yeah.
Yep. Then 5 pi over 3, 7 pi over 4, 11 pi over 6. Now we're ready to plot some of these points. So we had 0, 8, so I need to count out 8 circles. 7, 8, 0, 8, and then we had pi over 6, 7.5. So go in just 1/2 ring. Pi over 4, 6.8. So go in a little bit. Pi over 3 was 6. Pi over 2 was 4. 1, 2, 3, 4. 2 pi over 3 is 2. I find the wrong ring. 5 pi over 6 is 1/2. What do you think is going to happen between pi and 2 pi, looking at the graph? If you look at the Cartesian grid. I'll let you finish plotting your points.
Will it be like another dimple?
Well, this one isn't going to be a dimple. This one actually has a special name, but where do you think the points are going to go? How are they going to relate to the ones that we have already?
Will it be symmetrical?
They're going to be symmetrical. It's going to be symmetrical over the line 0 equals pi, or y, you know, the 0 pi ring. Yeah, so we can take all these points. So 5 pi over 6, we had 2, which half, which means 7 pi over 6, we're going to have a half. Alright, so we're just gonna flip all these points. Okay, and we had 2 pi over 3, which 2, that means 4 pi over 3. Oh, did I skip one?
Yeah, 3 pi over 4.
3
Oh,
pi.
you didn't have one there.
Did I skip one?
You skipped pi.
I skipped 3 pi over 4.
Yeah.
Oh, so let's put that on there. 3 pi over 4 is 1.2. 3 pi over 4 is 1.2. So let's put that on. Skip
No.
that. 3 pi over 4, 1.2. Now we're going to do 5 pi over 4, 1.2. And then 4 pi over 3
2.
is 2. I'm in the wrong place.
And then 6. Oh no, not 6.
And then 3 pi over 2
4.
is 4. 1, 2, 3, 4. And then pi over 3 is 6, so that means 5 pi over 3 is 6.
Where's 4 pi over 3?
6. 4 pi over 3 is the same as 2 pi over 3, so 2.
So 2, okay.
Yep, and then 7 pi over 4 is the same as, if I do that one, pi over 4. So that's going to be 6.8. And then we have one more, 11 pi over 6, which is the same as pi over 6. We're just flipping these over. So that's going to be 7.5. Okay, and now we're going to sketch this. I skipped pi 0. Gotta pop that too. Put pi 0 on there. So now we see that's not actually a dimple. I'm going to connect these. And you're really going to like this one. This one's a fun one. And this guy, what's it look like? This is called a cardioid, because it kind of looks like a heart.
What? It looks more like a peach.
Maybe. So this one, right, this one actually comes into the pole. The dimpled one didn't come into the pole, this one comes into the pole. Okay? And the next guy, there's 3 types of limacon. So there's a dimple, there's a cardioid, and then there's this last one. So we'll see how much time we have for this. If we don't finish, and I'll make a video to finish this part. Okay? All right, so let's go ahead and plot this in the Cartesian plane. Okay, so what's our midline?
3.
Good. So midline is at y equals 3. Put that on. Okay, what's our amplitude?
5.
5. So that means we go up 5 and down 5. So we go from 3 up 5 will put us at 8. Is everyone feeling okay about graphing these in the Cartesian plane?
Yes, we haven't done a sine line.
We're going to explore that.
Different?
Yeah. But we can make some guesses about what's going to happen. What do you think is going to happen when it's sine instead of cosine?
It's gonna go like up.
Yeah, it's going to be vertical instead of horizontal, right? So we're going to make some guesses about what's going to happen. Okay, so now we're going to start graphing this. This is cosine, so where does it start?
At 0, 8.
It starts at 0, 8. It's a positive cosine, so it has to go down. So we've got 0, 8, pi over 2, 3, pi negative 2.
Why'd you write y equals 0?
What's that?
Why'd you write y equals 0?
That's the midline. Oh, I wrote the wrong thing. I don't know why I wrote that. Thank you. 2 pi 8. Thank you. Okay, then we're going to sketch this. And we're going to put the points from the Cartesian to the polar. Okay, so I am going to put all the angles on again. Pi over 4, 2 pi. This is pi over 3. I'm hurting the mount of the smartboard. I'm writing so many things. I write hard. That's part of my problem. 3 pi over 4. 5 pi over 6. Pi. 7 pi over 6. And let's see. 5 pi over 4. 4 pi over 3. 3 pi over 2. Okay, we're good? All right, so this is actually a critical thing, okay? On this graph, I want to point this out because I don't know how much time we have. You notice that the graph is crossing beneath the x-axis.
Yeah.
In our previous graphs, we never had something cross the x-axis. It can always be above or would always be below. So what happens when we have negative values here, we have negative r values. What happens when we graph points with negative r values? I'm going to write negative here.
It's gonna be like, not exactly, like the two, when we graph the first points, they won't be exactly like reflected over the other
That's
axis.
what it's called.
Well, what happens in general? If we have something with a negative r value, what do we have to do? It's going to be flipped, right? So these are going to flip over the pole. And this is going to be important. That what's going to happen when something flips over the pole. That's what's different about this graph than the previous graphs. Okay, so I'm going to start labeling some of these points. Okay, once again, I found these just with my calculator. If we drew a nice graph, you could get them from your graph. Okay, so this is pi over 6, 7.3. Pi over 4 is 6.5. Pi over 3 is at 5.5. Oh, I drew this very well today. So proud of myself. Pi over 3. See, if you have low expectations, then you can be happy with yourself. Pi over 2, 3. 2 pi over 3 is 1/2.
That goes down a lot.
What's that?
That goes down a nice amount.
3 pi over 4 is negative 1/2. 5 pi over 6 was negative, or is negative 1.3. So I'll put that here. 5 pi over 6 is negative 1.3. And then pi, that's an exact point. Okay? And then we see we have symmetrical points, right? You see along this line theta equals pi. We're going to just flip these guys over. It's going to be symmetric. Okay, so let's start plotting these points and see what happens. Okay, so I'm going to plot 0, 8 once again. 2, 3, 4, 5, 6, 7, 8. Okay, 0, 8. Then we've got pi over 6, 7.3. So come in a little bit. Then we've got pi over 4, 6.5. Then we have pi over 3, 5.5. Then we have pi over 2, 3. Then we've got 2 pi over 3, 1/2. Then we've got 3 pi over 4, negative 1/2. Okay, so 3 pi over 4, negative 1/2 means we're going to flip it over the pole. So it's actually going to be on the 7 pi over 4 ray. Okay, flipped it over the pole. Then we've got, okay, so I'm going to have to finish this on a video, but at least you got like the general idea. And then I'll do a little exploration on Desmos so we can figure out what happens.
Okay.
Okay, I apologize for having to make so many videos. It's just we don't have that much class time, so.
No, it's okay. Thanks for
It's
making
okay?
Yeah.
Okay. Yeah.
When you have, so you got the 1/2, and then you got the negative 1/2. When is it again that you would transform the 2 pi, if it's 2 pi over 3 to the pi over 3?
2 pi over 3, if you take that across the pole, is going to be on 5 pi over 3.
So when would you do that?
If you have a negative value, so if I plotted like 2 pi over 3, 3, let's say 1.
What am I gonna do?
If you have, let's say, oh,
What?
okay, let's do it over here.
It's really
So
worse
if
than
I
a class
have-
where you're just like in fear of getting called up.
Let's say this is 2 pi over 3.
Like I have to have
If
it.
you flip that over,
Like,
now
they're
that's
getting
at
things
5
right.
pi over 3.
Well, first of all, should I just
Right?
call it
Okay,
business
so if
class?
I want to
It's
plot
like if I
negative
get
2
something
pi
wrong, it's
over
not
3,
it's like
that
okay,
would
it's
normally
educated
mean I
guess,
go
you know?
out 2 circles along 2 pi over 3. But it's a negative, which means I actually go out 2 circles on 5 pi over 3.
But he always gives me
So this point is negative 2 pi over 3.
Really?
It's the same point as
he knows that I'm dumb.
2 5 pi, actually I'm writing these, yeah, 2 5 pi over 3.
Except
That's the same point.
you just wanted 1/2. You had 1/2.
Oh, so 1/2, so if it were,
negative 1/2.
yeah, if it were negative 1/2.
But then why'd you put it here?
I don't know, maybe I plotted it wrong.
Okay. I don't know. You plotted in the.
Was it 2 pi over 3? I think 2 pi over 3 was positive. I think it was 3 pi over 4.
That is quite. Oh yeah, that's quite positive.
Yeah.
Okay, gotcha.
Okay, so let me stop this.